In this video, we'll be looking at what transformers are and how they work. No, not the giant robots that can transform into cars, but an electrical device that changes the voltage of an alternating current supply. Don't worry if that doesn't make sense yet, because it will by the end of the video. In an alternating current, the electric charge periodically changes its direction of flow around the circuit. To learn more about alternating and direct current, watch this video. The great thing about alternating currents is that a transformer can be used to change the voltage. It can change high voltage supply into a low voltage one, or vice versa. Transformers consist of a pair of coils wound around a soft metal core. They have a primary coil, a secondary coil, and a soft metal core which is usually iron. A transformer requires an alternating current, or AC power supply, which creates the alternating current in the first place. The alternating current passes through the primary coil, wrapped around a soft iron core. This induces a changing magnetic field in the core. The changing magnetic field, like a domino effect, induces a changing magnetic current in the secondary coil. This alternating magnetic field in the secondary coil induces an alternating current in the circuit connected to the secondary coil. Depending on how many turns the coils on each side have, the new output will have a different voltage. A stepped-up transformer has more turns of wire in the secondary coil than the primary coil, which in turn creates a larger induced voltage in the secondary coil. As the output voltage is larger than the input voltage, it is called a stepped-up transformer. A step-down transformer has more turns of wire in the primary coil and less turns in the secondary coil. This creates a smaller induced voltage in the secondary coil. The output voltage is smaller than the input voltage, hence it's a step-down transformer. We can calculate the voltage produced in the secondary coil by using this equation. The voltages in the primary and secondary coils, and the number of turns in each coil. So let's work out an example. Calculate the voltage in the secondary coil. Using our equation, we can substitute in the values we already know. The primary voltage is 30 volts. The primary number of turns is 20, and the secondary turns is 5. A simple bit of rearranging, and the secondary voltage is 7.5 volts. So the output voltage of 7.5 is less than the original supply of 30 volts. Is this a step up or a step down transformer? A step down, of course. Pause the video and give these questions a go. Did you get them right? A 6000 volt step up transformer and the step down transformers start with 1000 volts. Transformers are used in the real world in the transfer of electricity from power stations to our homes. When a current flows through a wire, some of the energy is lost as heat. To reduce these losses, electricity is transmitted at a low current. This needs a high voltage. Step-up transformers are used to increase the voltage up to 275,000 volts or even 400,000 volts sometimes. These high voltages, however, are too dangerous to use in your home, and so a step-down transformer is used before the electricity enters your home to reduce the voltage back to safer levels. This explains why near power lines there are danger high voltage signs. In this video, we've learnt what transformers are, how they work, and how to calculate the voltage produced by a transformer. Thanks for listening.